Now basically we have learnt types of triangle based on sides. One is equilateral, isosceles and scaling triangle. How to show that these 3 points represents a equilateral triangle. I need to show that opposite sides are equal and diagonals are equal. So let us calculate the distance between all possible sides and diagonals. Center of the circle is nothing but the midpoint of the line segment or the midpoint of the diameter. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today we are taking up the new chapter, Coordinate System in a Plane. So we know that we know to denote the coordinate points in a coordinate system in a plane. So using the concept of denoting the points, here we are going to calculate the distance formula, section formula and area of a triangle whenever 3 points are non-collinear. But before that, let us see the weightage of the chapter coordinate system in a plane. From this chapter, you will get an essay type of a long answer question for 5 marks. So basically the question will be on the distance formula. So where you can take the few problems related to it. Now here in this session, we are going to discuss about the distance formula, section formula and area of a triangle using the coordinate system concept. Now the first one is the distance formula. Suppose we have any 2 points in the coordinate system. We know this is x-axis and this is y-axis. So we need to consider this as point P and this is considered as point Q. So we need to calculate the distance between them. Suppose P has a coordinate of x1, y1 and Q has a coordinate of x2, y2. Then the distance between them is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. So remember, here the distance is always positive because measurement is always positive. Now suppose if the points lie in the second or third or fourth quadrant, even though my points are negative here, but the distance will be always positive here and hence it is always the square root of x2 minus x1 whole square plus y2 minus y1 whole square. It can also be written in the form of x1 minus x2 whole square plus y1 minus y2 whole square. It's one and the same because here we are squaring the number, it will be positive. And square root of a positive number is finally the positive itself. So therefore, the distance between any 2 points is the length or the line segment joining them and it is given by the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now, learning this distance formula helps us to conclude many things. The first point is, whenever 3 points are collinear, for instance, let me consider point A, P, B are collinear. So what do you mean by collinear? All are lying in the same straight line. So whenever points are lying in the same straight line, using the distance formula, we can conclude these 3 points are collinear. How? You can clearly see the distance of AP plus the distance of PB is equal to the distance of AB. So that is AP plus BP is equal to AB here. So this indicates the modulus. Modulus means whatever the value you get, you should write it as a positive value since we are talking about the distance. So this is one of the application of the distance formula, that is we can prove that 3 points are collinear using distance formula. One more thing is with triangles. Now, if 3 points are not collinear, obviously it should be non-collinear. Somewhere, obviously 3 non-collinear points will form a triangle. Now basically we have learnt types of triangle based on sides. One is equilateral, isosceles and scaling triangle. How to show that these 3 points represents a equilateral triangle. So suppose we consider these 3 points as A, B, C. It forms a equilateral triangle if all sides are equal. All sides are equal means the distance must be same. So therefore here if we show that distance AB, distance BC is equal to distance AC, then it forms a equilateral triangle. Now if I want to show that it satisfy only the conditions of isosceles, then it is enough to show that any two sides, AB or BC, BC or AC, or it may be AB or AC. If you show that they are equal, any two sides are equal in a triangle, then it forms a isosceles triangle. Now suppose if this forms a right angle triangle. So this is 90 degree. How to show that? The vertices or the points represents the right angle triangle. So we know the Pythagoras theorem, that is the square of the hypotenuse is equal to the sum of the square of the other two sides. Now according to this, if we show that AC square is equal to AB square plus BC square. So here again AC, AB, BC are all distance. So the same formula, if you substitute square, we can write without square root. So if you square it, then we can write the formula without square. So here AC square is equal to AB square plus BC square is a Pythagoras theorem, and if it satisfies by all these points, then it forms a right angle triangle. So now one more application of distance formula is to show that what type of quadrilateral it can be. Now consider 4 points here. So let me consider A, B, C, D. So non-collinear points again. So when there are 4 non-collinear points, how to show that it is a square? So we know the property of a square, that is all sides must be equal, diagonals must be equal. So if ABCD forms a quadrilateral, then to show that it is a square, show that distance AB, distance BC, distance CD and distance AD are equal. Also AC and BD, the diagonals. So diagonals AC is equal to BD. So this is to show that this quadrilateral is a square. Now what in case if it forms a rhombus? So if in case it forms a rhombus, in rhombus we know that all sides are equal but diagonals are not equal. So if we show that AB is equal to BC is equal to CD is equal to AD and diagonals are not equal here, that is AC is not equal to BD, then it forms a rhombus. So same case in case of rectangle and parallelogram, we know that both in case of rectangle and parallelogram opposite sides are equal. So therefore to show that it is a rectangle or a parallelogram, we can show that if you consider this opposite sides can be AB is equal to CD and AD is equal to BC. Also diagonals are equal here, AC is equal to BD. But here opposite sides are equal, that is AB is equal to CD and AD is equal to BC, but diagonals are not equal, AC is not equal to BD. So using the distance formula, just calculating the distance of the sides of a quadrilateral, we can decide whether it is a square or rhombus, a rectangle or a parallelogram. So these are some important applications of distance formula. So one is that we can say whether the points are collinear. Other, if the points are collinear, then what type of triangle they might form or what type of quadrilateral they may form. Let us see the problems now. Find the distance between the following pair of points 4, 5 and -3, 2. So let me consider this as point P and this is point Q. This is x1, y1, this is x2, y2. Then using distance formula, PQ is equal to x2 minus x1 whole square plus y2 minus y1 whole square under the square root. So now x2 is -3 minus 4 whole square. y2 minus y1 is 2 minus 5 whole square under the square root. So this is -7 square 49 plus 2 minus 5 is -3 minus 3 whole square is 9. So this is equal to root 58 units. Next question. Find a point on the x-axis which is equidistant from -6, 4 and 2, -4. So we have a coordinate axis here and this is our x-axis. So we have a point -6, 4 somewhere in the second quadrant and the 2, -4 somewhere in the fourth quadrant. So obviously it is at an equal distance from a point on the x-axis. So we need to find out the point. So any point on x-axis, can be represented as x, 0 because on the point on x-axis y value is 0. Suppose if this is a point, then it is in the form of 2, 0, 3, 0, etc. like that. So the point of y is always 0 on the x-axis. Now they have given it is at equidistance. So let me consider this point as P and this point as A and this point as B. So they have given it is equidistance. So which means I can say AP is equal to BP. So now AP, let us calculate the distance between them. So AP is equal to BP, can square on both sides, then it becomes AP square is equal to BP square. Why I am squaring? If you square it, then distance formula can be written without square root. So now let us apply distance formula for AP. So if we apply this, then it will become x minus of minus means plus 6 whole square plus 0 minus 4 whole square. Again BP square. So BP square is again x minus 2 whole square plus 0 minus of minus plus 4 whole square. So now here let us expand this using a plus b whole square, a minus b whole square formula. So this is x square plus 36 plus 12x and here it becomes plus 16. Here x square plus 4 minus 4x plus 16. We can cancel x square on both sides. We can cancel 16 on both sides. Then 12x minus 4x when it comes here, then it becomes 16x. We have 4 here. When it goes there, it becomes minus 36, 4. So which becomes 32. Now x is equal to minus 2. So therefore, the value of x is minus 2. So therefore, the point P x, 0 is P minus 2, 0. So that means minus 6, 4, 2, minus 4 is equidistant from the point minus 2, 0 which lies on the x-axis. Next question, find a point in the second quadrant which is at a distance of 2 units from the x-axis and 5 units from the y-axis. So let us consider this as the coordinate axis. So we know this is first quadrant, second quadrant, third quadrant and fourth quadrant. So we have a point P in the second quadrant which is at a distance 2 units from the x-axis. So from the x-axis 2 units. So this is 2. So that means point P x, y is equal to, so which is at 2. So therefore which means x is equal to 2 here. So distance from x-axis is nothing but y. So distance from x-axis is nothing but y. Similarly, distance from y-axis is nothing but x. And distance from y-axis is given, that is 5 units. So therefore, so we have the point 5 here. So therefore, this point can be written in the form of, since in the second quadrant we have minus values of x here. So x value is minus 5 and y value is 2. So therefore, the point is minus 5, 2. Next question. Show that the following points are the vertices of the right angle triangle. So the points are given 10, 4, minus 4, 6, 2, minus 2. So let me take A is equal to 10, 4, B is equal to minus 4, 6 and C is equal to 2, minus 2. we need to show that it forms a right angle triangle. So let us calculate the square of all the sides. So I don't know where the right angle is formed. So therefore, let me consider this as ABC. Let me calculate AB square, AC square and BC square. So now AB square, or AB is nothing but the distance. So AB square without square root. So we can write here minus 4 minus 10. Minus 4 minus 10 is minus 14 whole square plus 6 minus 4 2 square. So which is equal to 196 plus 4 is equal to 200. Next we go with BC square. BC square is 2 plus 4, 6 square plus minus 2 minus 6, which is minus 8 whole square. So which is 36 plus 64 is equal to 100. Next we will calculate AC square. So AC square 2 minus 10 minus 8 whole square plus minus 2 minus 4 minus 6 whole square, which is 64 plus 36 is equal to 100. Now clearly we can observe here AC square plus BC square is equal to AB square. So that means the triangle is in this form. So this is your, it is right angled at C. So therefore we can clearly say AB square is equal to AC square plus BC square. Hence it is satisfying the Pythagoras theorem property. So therefore ABC forms the vertices of right angle triangle. Next question. Show that the following points minus 3, 1, minus 6, minus 7, 3, minus 1, 3, minus 9 and 6, minus 1 forms a parallelogram. Suppose any points forms a parallelogram. We have discussed in the application of distance formula that if any 4 points form a parallelogram, then we know that opposite sides are equal and diagonals are unequals. So let me consider this point as A, B, C, D. I need to show that opposite sides are equal and diagonals are equal. So let us calculate the distance between all possible sides and diagonals. So first let us calculate AB. So AB is square root of, using distance formula, it is x2 minus x1 whole square plus y2 minus y1 whole square. So minus 6 minus of minus 3 becomes minus 3 whole square plus minus 7 minus 1 is minus 8 whole square. So which is square root of 9 plus 64, which is equal to 73 units. Now let me calculate BC. So square root of BC is 3 minus of minus 6, which becomes 9 square plus minus 9 plus 7 is minus 2 whole square, which is 81 plus 4, which is equal to root 85. Next we will calculate CD. So CD is again 6 minus 3 whole square, which is 3 square plus minus 1 plus 9, which becomes 8 square. So which is equal to 9 plus 64, which is equal to root 73. Next we will calculate AD. So AD is equal to 6 plus 3, 9 square plus minus 1 minus 2 whole square. So which is equal to root 81 plus 4 is equal to root 85. Next, the possible diagonals can be AC and BD. So opposites vertices. So AC, we are calculating AC. So AC is 3 plus 3, which becomes 9 square, minus 9 minus 1, which becomes 10 square. So which is 81 plus 100, which is equal to root of 181. Next is BD. So now BD is 6 plus 6, which is 12 square, plus minus 1 plus 7, which becomes 6 square. So now this is 144 plus 36. So which is equal to root 180. Now clearly from the observation here, we can clearly see AB is equal to CD. So AB is equal to CD. And next we have BC is equal to AD. And we are getting AC is not equal to BD. So we can plot this as A, B, C, D. From the properties of parallelogram, we can say here the opposite sides are equal here. That is AB is equal to CD, AD is equal to BC. Also diagonals are unequal. So hence the points A, B, C, D forms the vertices of parallelogram. Next question. Find the circumcenter of the triangle whose vertices are 1, 2, 2, 1 and 2, 3. Also find the circumradius. So what do you mean by the circumcenter? Circumcenter of a triangle is nothing but the perpendicular bisectors of all the sides. So this center is called the circumcenter. So whenever we draw three perpendicular bisectors of a triangle, so the intersection of all these three perpendicular bisectors forms the circumcenter. So, and also if we consider the vertices are 1, 2 and 2, 1 and 2, 3. So the distance from the circumcenter to any vertices of a triangle will be same. Suppose I consider this circumcenter as S and this points are A, B, C. So from the figure we can say here SA is equal to SB is equal to SC. So now let us apply the distance formula for SA, SB, SC. So let me consider S as the point x, y. So from the figure using distance formula, here we can write this as x minus 1 whole square plus y minus 2 whole square. And here x minus 2 whole square plus y minus 1 whole square. And here we can write x minus 2 whole square plus y minus 3 whole square. So we have three equations here. So we can write them separately as x minus 1 whole square plus y minus 2 whole square is equal to x minus 2 whole square plus y minus 1 whole square. So let me consider this as equation 1. And similarly, I can write x minus 2 whole square plus y minus 1 whole square is equal to x minus 2 whole square plus y minus 3 whole square. So let me take this as equation 2. So let us solve equation 1 and 2. First I will solve equation 2 here because I have an equal quantity x minus 2 whole square on both sides which get cancelled. Now expand this, we have y square plus 1 minus 2y is equal to y square plus 9 minus 6y. We can cancel y square on both sides. So 6y when it comes here it becomes 6y minus 2y, so 4y. And 9 minus 1 is 8. So from this we can write y is equal to 2. Now if I substitute the value of y is equal to 2 here and expand x minus 1 whole square, then it becomes x square plus 1 minus 2x plus, if I take y is equal to 2 here, this entire thing becomes 0. So 0 is equal to here x square plus 4 minus 4x and 2 minus 1 is 1, so 1 square is 1. Now cancelling x square plus 1, x square plus 1 on both sides. So I'll shift to minus 4x there, it becomes plus 4x. We get 4x minus 2x is equal to 4. So this implies 2x is equal to 4. This implies x is equal to 2. So therefore, the point of intersection x, y is equal to 2, 2. Now, we got the point of intersection or the circumcenter of the triangle which is 2, 2. They also asked us to find the circumradius. So, circumradius means, so circumcenter means using this and taking this as a radius, we can calculate the radius of the circle. So which is nothing but we can calculate the distance between the circumcenter and any vertices of a triangle. So using SA, so we got S is 2, 2 and let us calculate any one of the vertices. So consider A, point A, which we have taken as 1, 2. So using distance formula, SA is nothing but square root of 1 minus 2 or 2 minus 1 whole square, which becomes 1 square, plus again 2 minus 2, 0 whole square. So the distance will become 1 unit. So therefore, the circumradius is 1 unit. So these are the applications of distance formula. The next thing is we are learning the section formula. What do you mean by section formula and why we are using section formula? Now consider 2 points and let these points are represented by AB. So let AB be the line segment or the distance between the point A and B. Let P be any point on the line segment. That means this P is dividing the line segment into 2 parts. So 2 parts in the ratio M is to N. Let M be the distance between AP and let N be the distance between PB. So that is in the ratio M is to N. Then what is this point or what are the coordinates of this point? This coordinates of a point can be found using the section formula. So thus, to find the coordinates of the point P x, y, which divides the line segment joining A x1, y1 and B x2, y2 internally in the ratio M is to N, and the coordinates of a point P is given by M x2 plus N x1 divided by M plus N, my2 plus ny1 divided by m plus n, which means here you can consider the point A as x1, y1. So let x1, y1 be the coordinates of point A and x2, y2 be the coordinates of point P. And this point P is dividing this line segment in the ratio m and n. So using all these constants and variables, and that constants and variable can be put in the section formula so that we can find the coordinates of x, y. So internally means the point is dividing them in between the line segment. So hence it is given by mx2 plus nx1 by m plus n, my2 plus ny1 divided by m plus n. Now suppose the same point divides them externally. So then the same formula can be written in the form of mx2 minus nx1 by m minus n, my2 minus ny1 divided by m minus n. Now suppose point P exactly divides in the middle. So then the distance or the ratio between them will be 1:1 because it will be an equal distance. When it is equidistant, obviously the ratio will be same, and hence here m and n value become 1. So therefore the formula become x2 plus x1 by 2 or y2 plus y1 by 2, or we can also write it as x1 plus x2 by 2, y1 plus y1 by 2. So here this gives you the x coordinate and this gives you the y coordinate of point P. Now let us take a problem. Find the coordinates of the point which divides the line joining the following pair of points in the given ratio. First one, 2, 4 and minus 3, 10 in the ratio 1:4 internally. So let me take this as x1, y1, this as x2, y2, and ratio is given as m:n, that is 1:4. So internally they are asking, so therefore let us consider the formula P x, y is equal to mx2 plus nx1 divided by m plus n, comma my2 plus ny1 divided by m plus n. So now m and n are 1 and 4, x1, y1 are 2, 4, for my1. So which can be written as m:n is 1:4. So here x1 is equal to 2, x2 is equal to minus 3. x1 is equal to 2, x2 is equal to minus 3. Next we have y1 is equal to 4, y2 is equal to 10. So y1 is equal to 4, y2 is equal to 10. Let us substitute these values here. So then we get minus 3 plus 4 into 2 divided by 1 plus 4. Next we have 1 into y2 that is 10 plus 4 into y1 that is 4 divided by 1 plus 4. So we have minus 3 plus 8 as minus 5 by 5, comma 10 plus 16, 26 by 5. So this is minus 1 comma 26 by 5. So this is the point which divides the given line segment joining these points in the ratio 1:4. Next question we have 1, 3 and 2, 7 in the ratio 3:4 externally. Externally means point Px, y is equal to mx2 minus nx1 by m minus n, comma my2 minus ny1 divided by m minus n. So let us substitute m, n, x1, x2, y1, y2. So here this is x1, y1, x2, y2, m, n. So now this becomes 3 into 2 minus 4 into 1 divided by 3 minus 4. Next we have m, 3 into 7 minus 4 into 3 divided by 3 minus 4. So now here 3 2s are 6, 6 minus 4 is 2, 2 divided by minus 1. Next 3 7s are 21, 4 3s are 12. So 21 minus 12 which becomes 9 divided by minus 1. So therefore the coordinates are minus 2 comma minus 9. So this is the point which divides the line segment joining these 2 points in the ratio 3:4 externally. Next question. Find the coordinates of the center of the circle having minus 3, 4 and 5, 8 as ends of the diameter. So we have a circle here and we have drawn a diameter whose ends are given, that is minus 3, 4 and 5, 8. So we are supposed to find the center of the circle. So this is, let this be point P. Center of the circle is nothing but the midpoint of the line segment or the midpoint of the diameter. So using midpoint formula, the point P x, y can be written as x1 plus x2 by 2, comma y1 plus y2 by 2. So therefore, here this can be written as minus 3 plus 5 by 2, comma 4 plus 8 by 2. So which becomes 2 by 2, comma 12 by 2. So which is equal to 1, 6. So therefore, the center of the circle is 1, 6. So the next thing is the centroid of the triangle. So what do you mean by the centroid of a triangle? So let me draw any triangle. So the point of intersection of all the medians of a triangle is nothing but the centroid of the triangle, and it is usually denoted by G. So which represents the centroid of a triangle, and if A, B, C represents the vertices of a triangle with point x1, y1, x2, y2 and x3, y3 respectively, then the centroid of the triangle is given by x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. So now let us take a problem on the centroid of the triangle. The centroid of the triangle ABC is 2, 3. The coordinates of A are 5, 6 and B minus 1, 4. Find the coordinates of C. So we have a triangle here A, B, C. A is given 5, 6. B is given minus 1, 4. They have also given the centroid of a triangle. This is given. So which is 2, 3. Now we need to find the coordinates of C. So let me consider this as x3, y3. So we have x1, y1, x2, y2 and the centroid. We need to find out C. So let me consider this point centroid as G. So G x, y is equal to x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. So centroid is given, so that is 2, 3. Now here this becomes 5 minus 1 plus x3 by 3, and here it is 6 plus 4 plus y3 by 3. So let us equate x coordinate with x coordinate. Then we'll get 2 is equal to 4 plus x3 by 3, or we have 6 is equal to 4 plus x3. So therefore x3 is equal to 2. Next, similarly we have 10 plus y3 divided by 3 is equal to 3 here. So 9 is equal to 10 plus y3, or y3 is equal to minus 1. So therefore the point C x3 comma y3 is equal to 2 comma minus 1. So this is the another vertex of the triangle. The next concept is area of a triangle. So whenever 3 vertices of a triangle are given, how to find out the area of a triangle? So basically we know the formula to calculate area as half into base into height whenever we know the altitude and side of a triangle. But here they have not given any sides or altitude on the triangle. They have just given the vertex A, B, C which forms a triangle. So if point A is x1, y1, point B is x2, y2 and point C is x3, y3. Here using this formula we can calculate the area of a triangle, that is half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So if you know the coordinates of the vertices of triangle ABC, then we can use this formula and find the area of a triangle. Now here we know that A, B, C are non-collinear. Any 3 points which lie on the same line segment, same straight line, cannot form a triangle. So only when they are non-collinear it can form a triangle. If suppose here, if area of a triangle becomes 0, that means the 3 points are collinear. That means they cannot form a triangle. So any value other than 0 if you get, then obviously they are non-collinear points which can form a triangle. Now let us take the problems on area of a triangle. Find the area of the triangle whose vertices are 6, 3, minus 3, 5 and 4, minus 2. So let me consider this as A x1, y1 as 6, 3, B x2, y2 as minus 3, 5. Next C x3, y3 as 4, minus 2. Now area of a triangle is half into x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. So now this is equal to half into x1 is 6, y2 minus y3 is 5 minus of minus 2 which becomes plus 2. x2 is minus 3, y3 is minus 2, y1 is minus 3. x3 is 4, y1 is 3 and y2 is 5. So now here half 6 into 7 minus 3 into minus 5, 4 into minus 2. Half 42 plus 15 minus 8. So which is equal to 49 by 2. Since we are talking about area, the unit is square units. So therefore the area of a triangle is 49 by 2 square unit. So similarly, whatever may be the vertices of a triangle given, we can find the area of a triangle using the same formula. Next one, show that the following points are collinear. A 4, minus 5, B 1, 1 and C minus 2, 7. So I have told you two concepts to show that the points are collinear. The one concept is if A, B, C lie on the same straight line. Suppose this is A, B, C, then AB plus BC should be equal to AC. So this is using distance formula. One more thing is, if you calculate the area of triangle ABC, the value should be equal to 0. Why? Because if they lie on the same straight line, they cannot form a triangle. Obviously, it doesn't cover any area and hence it has to be 0. So we can use any concept to show that the points of collinear. Now here I am taking the area of a triangle ABC concept. So let us calculate the area of ABC here. So area of ABC is equal to half into, so we know the formula x1 y2 minus y3. So x1 is 4, y2 is 1 minus y3 which is 7. Next we have x2 which is 1, y3 minus y2, so 7 plus 5. Next the last one is x3, so x3 is minus 2 and minus 5 minus 1. So let us calculate here half 4 into minus 6 plus 7 plus 5 12 minus 2 minus 6. So half we have minus 24 plus 12 plus 12. See here 12 plus 12 is 24, 24 minus 24 is 0, 0 into half is 0. Since the area is 0, we can say the points A, B, C are collinear. So therefore, we can conclude A, B and C are collinear. And similarly, if you show that the distance AB is plus distance BC gives you the total distance AC, then also we can show that the point ABC are collinear. So these are the few important concepts in the coordinate system in a plane, that is the distance formula, section formula, and to calculate the area of a triangle and the application of all these three concepts. I'll meet you in the next session with the new concept. Until then, keep watching, keep learning and keep exploring. Thank you.